Hello everyone, I want to show you guys this halberd that I made, okay? So true to how George Silver described it, basically when you stand here and raise your arm up, it basically comes up to the full length of your arm, okay? So this is a very lightweight weapon. If you look at over here, the blade is pretty thin, and most of the halberds that I've looked at, which are not ceremonial, most of the fighting halberds actually had a very thin blade. Um, Obviously this is not going to be hitting plate armor. This is really contemporary to the rapier, right? So this is like 16th century into the 17th century. This handles very much like a spear, okay? And then you've got a really good ability to hook things here, or here, or here. And this seems to have been used by common people like Landsknechts to defeat knights. Okay, and the way they use this is basically they would hook the knights on the horses, pull them to the ground, and then basically use the spike to reach into the gaps. Now these were cheaper; they were mass produced, so you could have a situation where you have like 20 or 30 Landsknechts against a versus a single knight, or those type of proportions, where you basically could have common people outnumbering more heavily armed knights and defeating them with a weapon like this. Okay, so a lot of times when people look at this and they see an axe here, they're like, "Oh man, it's a excellent chopper. It's going to cut through everything." And no, it's actually a pretty thin blade. I would not, obviously you can hit plate armor, but I wouldn't expect great results. But this is really good. Like if you picture like catching somebody like this, you pretty much got their arm trapped, right? Or if you hook them like this, you can pull them off a horse, right? Especially something like this, that's going to catch onto the different pieces of plate and the straps. So this is a really great hook over here, and also the backside. And then if you look at this long top spike here, I think it's about 14 inches. So I made this like in a diamond cross section, so it's really stout. But despite the fact that it's carbon steel, right? If I was to take this and basically swing really hard, right, and hit with that tip on something that's solid and immovable, I mean, if not the first time, but certainly after a few times, this is definitely going to start taking a bend. Okay, just because it's long and thin. All right, it's just under like a half inch. It's just under a half-inch thick. And what I did was like basically I turned it like this, so I get the benefit of a little bit more of a half-inch, because I'm hitting with with the points, right? So while it's about a half-inch thick, flat to flat, if you go point to point, you get a little bit more than that. Okay, but yeah, this is basically a spear with a hooking ability. That's how I see this being used. Okay, it's very lightweight, and it has to be in order to have something that's I think 88 inches long, right? So this is I think like 7 foot 4 inches. Okay, in order to have something that's this long and be able to swing it and recover, right? That head has to be light. Okay, so it has to be thin. It has to be thin here and relatively thin here in order to be useful. Okay, which doesn't mean that it's indestructible. In fact, when I look at like a lot of these museum pieces, it is very common for the spikes to have a bend in them. Okay, and I've listened to interviews of people that are actually handling originals in museums, and the spikes are very commonly have a bend. In some of them we can see how the pieces were forge welded together, because we can see basically defects in the forging process. Not all of them, but some of them do show exactly how they were forge welded together, which is actually really useful, because those are the pieces that I looked at, the imperfect ones, to figure out how these things were constructed. Okay, so a very common thing that I see is that the langets, right, that extend down, and basically attach the head to the shaft are usually broken, right? So these things, again, having to be relatively thin. I mean, these are about 1/8 of an inch on either side. Um, but still, I mean, just because it's long, if you're swinging at this and cutting down, you're putting a lot of pressure, back this way. So it is very, and I think a lot of the historical ones are actually even thinner than this. Okay, and they are usually broken, right? We can see that they're broken, and they have been reattached to new shafts, right, or newer shafts. A lot of times we don't know if this contemporary, if this was done in the same period, or if it was done centuries later for the purpose of showing it in a museum. A lot of times it's hard to tell, but we can tell that the langets are different. The rivets that hold it together are a little bit different. So what I did is I actually copied that onto this. So basically the langets off of the head come down to here, right? And then what I did is I made a shaft here where these side langets go all the way up to here, and then I riveted the two pieces together. And one of the things part of the reason why I did that is because I wanted to. I'm testing out like different thicknesses of shaft and different thicknesses of langets. So these langets here are about 1/8 on each side, but the ones down here are about half of that. They're like 1/16. So I wanted to do that and basically like just kind of like press on this and see like how much of a difference it makes. Again, on a lot of the historical ones, they do appear to be about a 1/16. Just from having put this together and handled it. I don't think that's a great idea, even though it might have been done that way historically. I think that 1/8 is a much better way. And the other thing is, a lot of times when we look at these langets, they're not that wide. I think that wider is better, especially in this area over here. So the next time I do this, I would think I would want to go a little bit wider. I mean, it can come a little bit thinner, but this area over here should be a little bit wider, I think. So yeah, so this is one type of a halberd and how it was attached. There's another one that I made. Kind of did these together, so kind of like almost side by side, because I wanted to experiment with these two construction methods. So this one here is fully socketed. Okay, so the wood comes up to about there. Okay, and one of the things that you notice is that the top spike on this is offset from the shaft, and that's something that, like, when I look at a lot of these historical halberds, a lot of times I'll see like it's almost like 1/3 of the time it's like in front, and then 1/3 of the time it's in line with the shaft, and 1/3 of the time it's behind it. And I was kind of trying to, like, I was wondering initially, like, why would they do that? Why wouldn't they just make everything in line always, all the time? And what I figured out from putting this together, right, is if I offset this, right, because this top spike here, right, inside it gets thinner, and it comes down to is that a bear? No, that's a deer. Like, what is making that noise? This one over here, right, the top spike comes down, it goes inside to up to about here, okay? And then what happens is the shaft comes up, and it comes up to about there. So these two overlap. Spike comes down to here, shaft comes up to there. So this gives me so without making this longer, because that's the other option, I could have just made this thing, come up longer, but by using this method of bringing the top spike down to here and then this up a little further up there, I'm able to gain some space. So it ended up being space efficient. Okay, so that's the answer to why the top spike and the shaft are sometimes offset like this. Because, like I said, in this one it comes a little further down, and it's stronger. Now, obviously, with this one I went thicker. So as I go thicker, it has to get shorter, right? Because that's the cost benefit, right? If I make this thicker, it starts getting heavier. If I make it thinner, I can go a little bit longer. So I'm here, obviously, I'm experimenting with both. Now, both of these ended up being almost exactly 5 pounds 2 ounces, right? The difference being that this one here is a little bit shorter, right? It looks like it's shorter by about 3 inches. All right. So this one is probably about 7 foot exactly. Whereas this one's, I think, about 7 foot 4 inches. So yeah, with this one over here, it's just basically, you can actually see the wood how it comes up to about all the way up there. It actually extends all the way up to there. See if we can get a view on the inside. Now you can't really. I'm trying to get a peek in there. So I actually posted another video of when I was actually constructing this and how I had to rivet the different parts together in order to get the pressure to forge weld this. Now, it basically, the forge welding on this didn't come out perfect. Like when I'm looking at this, I can kind of see like some of the forging lines. I can see the rivets very faint over there. I mean, they kind of blended in, but they're still there. I can see this forging line over here. So with a lot of the originals that are in the museums, you do see that, which is useful because, again, that's how I was able to like reverse engineer these things and figure out how they go together. Now, one of the things I was kind of thinking is I think I want to try and make another one and make it in line, and because on this one the shaft is almost 1 inch by 1 inch over here. I think if I taper the shaft like I did on this one, where I make it thinner, I think I can use less material and have less of an area that needs to be forge welded together. If I can limit the area that needs to be forge welded together, I can increase the chance that it's going to look good. Well, historically, with wrought iron, this was an easier method, right? Because there's no fitting the parts together. Wrought iron, if you get it hot enough and you put it in the fire, right, the two pieces actually stick. Okay, so when it comes to forge welding, basically the pieces should stick in the fire at least a little bit, almost like they're magnetized. Not that they are, but that's how it should kind of feel, and that will happen with wrought iron, or so I've been told. I never actually worked with wrought iron. That will not happen with modern steel. I've not been able to get the pieces to just stick together in the fire from touching them to each other. So yeah, so for me, making a halberd is actually a lot more difficult. But in period, right, during medieval times, this was an easier method with the wrought iron that they had, and that's why they could mass produce these and put these into the hands of common soldiers. So, and also this, like I said, this was also lighter. So, despite this being almost 7.5 feet long, or 7 feet 4 inches, I can swing it, recover, thrust. With the Poleaxe, the pieces need to be a little bit thicker because I needed to be able to fit them together. So there's some weight in this area over here, and also this is a different use thing. This was designed for knights to fight each other, okay, in chivalrous combat. Okay, so fully plated knights fighting each other in combat. The halberd was designed so that common people could defeat knights. Okay, so totally different use. So with this, I had to make this shorter. This is typically about the height of a man, about 6 foot or so, and it has to be that short in order for me to be able to swing this and recover. Okay, I mean, of course, you can always shorten it up, and you got a very fast, nimble weapon, but I still want that reach advantage. You know, at least get that first shot off. You know, from max distance. So yeah, two totally different weapons. It doesn't matter that this has a hammer and that has an axe, because I've actually built these so that they have an axe on one side. So that's not, you know, the fact that whether it has an axe or a hammer or a back spike, that's not so critical in its use so much as how it's built, how much weight's in the head, and how it's gonna handle it. So anyway, drop some comments. Let me know what you guys think. Also very interesting the way I designed this. I have these langets here that come all the way to the edge. So this is a hitting surface. Okay. So that works really good on the poleaxe. On the halberds, like on all the images I've seen, they're usually pretty thin. They almost never come all the way to the edge. Sometimes they have them in the front and in the back, but again, they're very thin. So like this one over here, which is about a 1/16. Like if this gets hit, this is gonna deform, right? So it's not gonna stay nice and shiny like this. It's gonna start to deform if it gets hit, just because of the thinness. And again, they use thicker ones, they use thin ones. It's just interesting to, you know, from actually having built these, to be able to see the differences of like what the thicker langets do versus the thinner ones. So anyway, drop some comments. Talk to you all soon.